All right, thanks, Tyler. We are going to talk about generator provisioning and installation today. I think this is a very interesting presentation, but then I tend to say that about all of them. This is when you buy a generator, generators other than small commercial units and residential units are all custom built. And so whoever quotes you that generator is going to go in and custom configure your generator, and then that generator is custom built to your requirements. So this presentation talks a little bit about options that we have on generators, as well as installation. I will give you some of my opinions in this, and I will tell you they're my opinions, and you're free to disagree. The volt is a fundamental unit of electrical measurement. It was named after an early physicist. What was that physicist's name? Give you just a moment. I should have brought along some Jeopardy music, but I didn't. The answer, of course, is John Travolta. Oh, no, wait, that's not right. It's Alessandro Volta, an Italian. All right, location. So this seems easy, but it often is one of the more difficult things we have in terms of installing a generator is figuring out where to put it. So you need entrance and exit points from the site. We have 5 feet from combustible walls. Now let me talk about the 5-foot rule a minute. Generally, inspectors, if they are familiar with generators, generally are going to have the 5-foot rule in their brain, and they're going to want the generator 5 feet from everything. But it's actually a little more complicated than that. First of all, the 5 feet is from combustible walls and building openings. So if you're near a non-combustible wall, then that 5 foot does not apply. Also, the generator cannot be installed underneath a building opening or underneath an air intake to a building. That's a not too common mistake, but fairly common because you don't look for the air intakes when you're siting the generator. In addition, if it's an indoor generator, the frame, the outside of the skid of the generator, they have to be 3 foot 6 inches apart. If it is, you've got the NEC to contend with, so wherever the circuit breaker is on that generator, when you open the door, you have to have your NEC clearance there, and generally under condition 2, that's 3 foot 6 inches. You've got doors on the enclosure. For service, the doors have to open, and so you generally leave about 3 foot 6 inches for the doors to open. Cooling, you want to have proper cooling. This particular generator, both of those in the pictures, show air exhaust going upwards, and that's really the best way to do it. And for Generac, that's pretty much standard in all of their smaller generators. Now you might say, well, I've got a standby generator by my house. It's not 5 feet. Well, no, that's another little exception. If the generator is in an outdoor non-combustible enclosure, and it's shown that that will prevent a fire from causing something next to it to catch on fire, then you can put it within 18 inches. And so with these residential generators, typically they're all serviced from the top. So you don't need the 3 foot 6 inch clearance for your electrical, and you can put those as close as 18 inches. I did just a little quick write-up on this and sent it to Tyler, and so he'll be sending that to all the people who attended last week's webinar. If you weren't on last week's webinar and you'd like a copy of that, just contact Tyler. It's nothing fancy. It's just something that kind of goes through the things that I mentioned because they're hard to remember. And so it's nice to see a little list and to be able to go through and check things off. Overhead interference points depends on your crane and sometimes your electrical, but mostly the crane. You need to be able to get that generator in and set it down without hitting an overhead line. That's one of the causes of fatalities is cranes touching overhead lines, and then people on the ground may suffer severe injury or even death because of touching that. Your electrical interconnect, your fuel source location, your exhaust discharge location, airflow, security, big one, flooding, and finally sound. And we'll talk about a lot of those others as we go along. Now, some people don't really have room, or they just don't want the generator to take up room and they would like to put it on a rooftop. This is not terribly common, but it's not uncommon either. I generally say anytime it's on a rooftop, you need to check with a structural engineer. Typically, if you have a generator 200 kilowatts and below, most rooftops are structurally sound enough to support that. But for me, even if it's 1 pound, I just say this thing needs to be checked by a structural engineer. And if it's a natural gas generator, then of course you can just pipe the natural gas up to the roof. And obviously I highly recommend natural gas generators for rooftop applications. That doesn't mean you can't have a diesel fuel on the roof, but if you do have a diesel fuel generator on the roof, you're going to have the tank down at ground level so they can fill it, and to keep lots of diesel fuel off the roof. And then you'll have to have a smaller day tank on the roof next to the generator. And so now it's going to require some discussions with the fire marshal, take a look at the roof material. It's not ideal, but it can be done. And then you have a pumping system, of course, that pumps to the day tank on the roof. You may need vibration isolation. Typically, the vibration isolation is already built into the generator, and you don't want to add anything else. But you can see here's a picture of a structural engineer who designed quite a little platform here to distribute the weight of the generator over a larger portion of that roof. Indoors, you need to worry about the things that you see on the screen. And I'm going to talk about indoor generators here in just a moment, but you can just scan those things on the screen. Now here's a diagram in one of the standards produced by one of the generator manufacturers, not Generac, and it shows an indoor location. So I would like you to take a look at this diagram and tell me if you see anything that you don't find appropriate, anything that violates codes, or things that just should be done differently. Give you a second and then we'll begin going through this. First of all, let's look at the conduit and attachments to the generator. Generators vibrate, so anything that's attached to the generator has to have a flex coupling. Well, here's our sheet metal going to the exhaust louver. That's got a flex duct on it. Your silencer has a flex coupling. It shows the conduits here have flex couplings, flexible fuel lines to the day tank, and flexible to the battery. So that looks pretty good to me, and I think they did a good job, and the artist let you know that that's important. How about those batteries? Is that a good place for batteries? Well, obviously not. And I've never actually seen batteries that quite look like that. There are people that will have batteries in a battery rack, but you certainly don't want the batteries on the ground where they're going to get dirty and they could be subject to water if there were some kind of a flood. Generally, batteries are put on a battery rack that's permanently mounted to the generator. That's pretty standard. Then the batteries are up, really sitting on the generator. The battery cables are quite short, and that's a good place for batteries. Now over here is an automatic transfer switch, and then you've got your battery charger. I think this is not the best place for a battery charger over here. Not saying you couldn't use it, but battery chargers are very sophisticated these days, and you really don't want the voltage drop between that battery charger and the battery. And so typically we're going to mount battery chargers on the generator. Not a code issue, but just something that I would do if it were me. Now, how about this inlet air opening? Is that large enough? Well, right here is the radiator, and you can see the radiator comes through the flex duct, and then the sheet metal flares out to the louvers, and the air exhausts outside the building. I like that. That all looks great, exactly how it should be. Now, take a look at the size of the radiator, and the inlet air opening should be 1.5 to 2 times. I would like to say 2 times the size of the radiator, and that should be the clear square foot or square inches of the inlet or opening, not the size of the inlet opening, but how much free airflow there is in there. I understand this is just a drawing and I'm being picky, but I would say the inlet air opening is undersized, and this can be a common problem in generators, that you have an air restriction because the inlet air opening is too small. Now, typically, if the inlet opening is just open louvers, then what you're going to have is a cold building. So in that case, most inspectors, and you need to check with the inspector, would not require the fuel vents on the tank to go to the outside if it were a diesel generator. But if that is motorized louvers, then they definitely would. And of course, motorized louvers are nice because you can keep the building warm, because they keep the airflow from circulating through the building until the generator actually starts operating. Please be aware that they have to be spring open. That is a code provision. So if you ever lose power, they will open. And then the generator simply interrupts the power to those louvers and the spring opens them. So you need power to keep them closed. Let's take a look at the radio, or the muffler, or we call it silencer generally in generator parlance. You've got a wall thimble that protects the wall from the heat of the generator. That's good. The silencer's up here. I noticed that there is no blanketing here to prevent people from touching that and getting burned. Blanketing is something that we really ought to have. I certainly understand why they wouldn't put it there in the drawing, however. Now, which way does this tilt? Does this tilt towards the generator, or does this tilt away from the generator and towards the outside? Well, to me, it pretty clearly tilts towards the generator. That's a code violation. This pipe must have a slight downward slope towards the outside, not towards the generator. The reason for that is when you combust materials, whether it be natural gas or diesel fuel, those are hydrocarbons, and hydrocarbons create water. And we do not want that water to flow back into the engine. It can ruin the engine. Also, right here before it goes vertical down into the engine, you have to have a drain line. You have to have a pipe that goes down that's able to accommodate a certain amount of water, and then some way of draining that water from this line in case that happens, and not there. So that again is a code violation. Over here you've got your day tank. There are, although with an inlet opening that it's not motorized, they may be okay with that. Typically you need to have vents on the day tank that go to the outside and not into the room. Now you've got your flex fuel lines, and you notice the main fuel line tank is down here. And so the suction line comes from the day tank into the generator. That's fine. But the return line goes from the generator back to the day tank. That is not where it should go. That makes the hot fuel from the day tank heat up the day tank and can make that fuel too hot. Return lines, when the main tank is too low, when the main tank is lower than the day tank, should always go back to the main tank, not to the day tank. And they, of course, don't show the pumping system there, so there's more complications. What is my point here? My point here is not to pick on the people who made this. My point is that there's a lot to think of in an indoor application of a generator. Generally, the electricians installing this thing may not know all these little picky rules that come with putting in an indoor generator. And so I would say most of the time when I go in and look at indoor generators, I find code violations there. And I don't blame people. The codes are very complicated. So moral of the story, if you can put your generator outside, it's better, it's cheaper, you don't have to have a room, and all of these things are naturally taken care of by the manufacturer of the generator. However, if you really want your generator inside, we can certainly do that. Just be careful of the codes. And here's a manufacturer of a generator who put this in a standard, and it's kind of funny that it has several code violations. All right, separate room. Level 1, remember level 1 is emergency generators for life safety. Those need to be in a separate room if, of course, they're indoors. That room should have a 2-hour fire rating. Typically, we'll have a fire protection system, which is almost always water sprinklers. The fire risk evaluation, battery-powered emergency lighting, and minimum access spacing of 36 inches. And it depends on the NEC. If there are I don't know, I shouldn't have opened up Pandora's box here, but there's condition 1, 2, and 3 that could require 36, 36 and a half, or 4 feet to any electrical panel. And you can refer to the National Electrical Code for that on clearances. But the generators, the base of the generators need to be 36 inches apart. So this is from the outer end of that U-frame, the base of the generator, to the outer frame of the wall or to another generator. Now, airflow is pretty important here. You can see up there in the upper right-hand side, we're going to have a problem there because this is a generator that exhausts horizontally. The air comes out at quite high velocity, goes through that radiator, and when it goes through the radiator, it's going to hit a wall. And that is going to do 2 things. Number 1, it is going to create a high pressure zone in there, which is going to cut down on airflow, which is likely going to cause the generator to overheat. Number 2, it's going to allow that exhaust to circulate around and come back into the generator. So now the incoming air to the generator is hot. A good way to, now we could have put a chain link fence there and that would have been fine. Make sure that we have, a great deal of distance there so that it doesn't create a high pressure zone. But a better way of doing it is this upward directed exhaust here that you can see. In this case, the air comes in on actually 3 sides of the generator. On this side that you see, and on the opposite side, and then on the end, and then the air is exhausted vertically upward. This also means we can generally put the muffler or the silencer in the exhaust hood and exhaust upward. If you have multiple generators, one of the nice things about those is that you have a lot of flexibility in terms of where you're going to mount that generator. By the way, up here on the upper right, even if you have upward directed discharge, you still have to make sure that you have some louvers to allow air to go in and basically not cause a high pressure inlet on the air going in. And they have done that. So inlet's fine, the outlet's got a problem. Here's a wall. For reasons that I will never understand, some people don't consider generators aesthetically beautiful. If you want to hide your generators, a wall is a very inexpensive way to do that, and it is also a very inexpensive and very effective way of reducing your noise level. So, materials, we typically have steel is the standard material, and with paint systems these days, it generally works very well. If you are near the ocean, you have salt spray, you have corrosive gases, then you may want to go with an aluminum enclosure. Aluminum is typically a higher cost, but in some residential generators, it's simply a standard on that generator. But for the most part, it's higher cost. Stainless steel, rare. I've never actually sold either an aluminum or a stainless steel generator in any significant size, but a stainless steel generator would be a pretty pricey option. Here's the air inlet. We already talked about this, the opening into the room. This would be for an indoor generator, 1.5 to 2 times the radiator area. And there is a formula so that you can calculate this. And then the air outlet, we should match the radiator size and then flare out to the louvers on the outside of the building. Make sure, of course, that your air inlet and your air outlet are on 2 different sides of the building. I've actually seen some locations where they had the air inlet and the air outlet like right next to each other, and it's worked okay. I haven't seen a real problem, but clearly that means that hot air going out can turn right around and come in the air inlet, and that's not really what you want. There's your little diagram of air coming in, air going out, and of course the ambient air temperature makes a great deal of difference also. Exhaust, you need a flex connection. You need condensate traps. We talked about that, the little tube that allows you to drain and allows the water to go into the condensate trap and not back into the engine. Allow for thermal expansion, have exhaust blankets, a thimble, have acceptable back pressure, and the silencer can be either a residential silencer or industrial or critical or hospital grade. There is typically not a great deal of difference sound-wise between critical and hospital grade. Generac, on all of their industrial generators, will provide a critical silencer standard, and they tend to be very quiet. But you should never look at the silencer and determine how loud the generator is going to be from the silencer, because there are lots of other sources of sound within the generator. So we see specs sometimes that want to know what the dBA is of the silencer, and 10 feet from the silencer, it doesn't say which direction from the silencer. Not a good way to specify these things. You need to look at the total sound from the generator. Here's exhaust. You can see that above the generator, there are some windows that can be opened. And so we've taken the exhaust pipe up quite high. As you would guess, if you bring the exhaust pipe up that far, then you're going to have to make that exhaust pipe larger in order to prevent excessive back pressure on the engine. Excessive back pressure on the engine is going to limit the amount of power that engine can produce. Well, how would you size that? The answer is we have a computer program. Our computer sizing program will size natural gas lines for you. It will size the exhaust discharge pipe. It's a very handy tool. These show different places for the exhaust. In the lower left, we've got our standard with the muffler on top, and that doesn't even look good when it's new. But typically, the first part to rust is going to be that silencer on top. And then the exhaust from the silencer is right there on top. It doesn't come out at a high velocity. It's really better to put that in an exhaust scoop like we have in the upper right-hand corner here, and then you can't see the muffler, and the smoke or the particulate that comes out of the engine is going to join with the airflow through the generator itself that's cooling the generator, and it exhausts at quite high velocity and blows it up into the air. Typically with today's EPA engines and this type of system, you won't even see any smoke that was so common in years past. This is called a nested muffler on the bottom. It's a design that is available in some generators, particularly the large ones. In this case, the silencer or the muffler is rectangular, and it stands, roughly maybe a third above the generator, and then the other 2/3 is down sitting inside the generator enclosure, which is why we call it a nested muffler. It's kind of nested in that enclosure. Anything inside the enclosure for exhaust should be thermally wrapped, and the generator manufacturer will always do that. Block heaters. Block heaters are very important for diesel engines. It's the most important thing you can do is make sure that engine is warm, because they are compression ignited, not spark ignited. So typically we use a block heater that is a circulating type where you just heat the fluid, the coolant, and the coolant naturally flows by convection up and through the generator. And that's a very slow cooling process, but it works, or heating process actually, but it works just fine. When you get into some very large generators, then you may have to have a pump on there or even multiple heaters. Typically, we'd like to keep the engine block at 100 degrees. And so that's one of the things you should check daily when you go out and check your generator, is to see if it's warm. Spark ignited engines, not as important in terms of heat, but very important that you get a good crank on that generator. So oil, the type of oil you use, and a battery heater will go a long ways to make sure you get a good crank on that engine. Now, on larger generators or anywhere there's an emergency or legally required, We typically put block heaters on them anyway. But on a lot of the small residentials, particularly in areas that don't get very cold, you don't really need a block heater. Radiators, we won't talk about this a lot, but they're typically engine mounted. City water cooling that used to be appropriate years ago pretty much is gone. Now you can do a remote radiator that gets the heat away from the engine. Maybe you've got the engine inside of a building or even in a basement. You want to get that heat out. Sometimes you can put the radiator outside. This has gotten more and more problematic because on natural gas generators, typically you can't do it because of the EPA. It voids the EPA warranty. On diesels, you can, but you need to work carefully with the manufacturer because there are EPA restraints these days that didn't used to be the case. Here's some basic design considerations that hopefully you've had time to scan there. Here's a remote radiator, and it talks about the charge air cooling. And we won't get into remote radiator design. Pretty uncommon these days, but it still is a possibility, at least on diesel engines. Sound levels. This shows typical sound levels on a generator, and what you want to do is get a sound level on the entire generator. Now here's some sound attenuated enclosures. Sound level is measured on a flat asphalt surface 23 feet from the generator. Why do they do that? Well, 23 feet is about the level at which the sound gets more uniform as you walk around the generator. And if you go up closer to the generator, the sound level varies dramatically depending upon the height of the microphone and exactly where it is in reference to the generator. So 23 feet is a standard. All of the sound measurements that you get from a CAT or a Cummins or a Generac or a Kohler are going to be at 23 feet. If you want to know what that is at 30 feet or at 40 feet, we have a calculator that we can do that calculation for you and tell you what that sound level is further than 23 feet. Closer than 23 feet, we can do it as well, but as I said, it gets a little squirrely because you have such non-uniform distribution of the sound. Now, typically you measure the sound on all four sides and you average. One manufacturer now is measuring the sound on 8 sides, so that would be the 4 sides and the 4 corners. Now that might sound better. In reality, all that does is allow them to quote quieter sound ratings because on the corners, the sound is lower, and therefore by measuring on the 4 corners, you can publish a dBA level that is lower than what that same generator would produce if you just measured the 4 sides. Generac does the 4 sides. A weather housing will typically reduce the sound about 5 dPA. A standard sound attenuated housing, which we now call level 1. They used to just be called a sound housing. Now it's level 1, about 15 dBA, level 2, 20 dBA, or you can go to a level 3, which is starting to get some acceptance, or you can actually build custom enclosures. For instance, on generators used in the cinema, they can't have the generator. They're filming outdoors. They can't have the generator sound on the soundtrack, and the enclosure can cost you a lot more than the generator. Now, I would not use these dBA levels. These are maybe typical, but it varies all over the place depending on what the generator is. So don't assume those dBA values are accurate, but every manufacturer can give you test sheet that shows exactly what their dBA is, and that's the way you should look at sound, not by looking at what the sound of the muffler is. Enclosure options, we can do fairly inexpensive enclosure upgrades to get lower dBA levels, but as you try to get quieter and quieter and quieter, the cost exponentially increases. You get 6 dBA reduction every time you double the distance, and as we said earlier, walls can be really nice there. Now, I had something I was going to say and I lost my train of thought. Oh yes, in terms of my preferences, my opinion, here's my opinion on this. I am a huge fan of higher sound level enclosures, sound level 2 enclosures. Now they cost. And so if I recommend them, you could say, oh, you're just trying to increase the price of the generator. But there are a lot of things that increase the price of the generator that I think are wasted. And I think sound level enclosure is not wasted. First of all, it prevents complaints from people nearby your facility that hear that sound. And they generally complain when the engine's exercising rather than when there's a power outage. But the second reason is if you walk up to a generator and it's screaming bloody murder and it's, then you're going to say, wow, this is not really a great generator. You go to another generator and it just seems smooth and quiet. By the way, quiet seems smoother. It may not be smoother, it may not have less vibration, but if it's quiet, it seems smoother. And if it's really quiet, then you say, wow, that's really quiet. And we can sit here and talk right next to the generator. So you will have a higher perceived quality of your generator if it's quieter. And so if you're a contractor, if you're an engineer, I would always try to persuade my customers to go to a level 2 sound enclosure because they're going to like it better. It's not going to be screaming. They're not going to get complaints. But most of all, they're going to see that generator as higher quality, and they're going to attribute that to you and your installation of a really high quality generator. The concrete slab, obviously, we want to make sure that the conduits come up in the right place. Pretty hard to move them after the generator is poured. And typically, we like to extend them 18 inches beyond the profile of the generator. That is not required. And maybe even most generators have less than that. It's nice in the rain to be able to walk on the cement and service the generator. But the code actually only says you really have to have cement under the actual skid of the generator itself. So exactly how to do the cement pad we can get into if you would like to call us on any particular generator. Typically, we like to see an 8-inch pad minimum with 3 inches above grade. The 3 inches above grade is to make sure that we don't end up with pooling water on the generator pad. The generator pad should always be flat. We do not slope generator pads for water runoff. And so the generator pad should be level within 1/2 inch from side to side or from end to end. Here's isolators. This is one of my pet peeves. We get specifications from engineers that specify that they want springs under the generator. Well, where do you put those springs? You can't put them between the tank and the generator because that's all custom designed. There's no room to put them there. And that is where the manufacturer will have isolators, but you can't put more springs there. So we have to put them under the tank. And now the tank, instead of having a nice flat surface, is sitting on these springs. And not only does that weaken the tank and increase the likelihood of cracks in the tank, but it actually can create problems in a seismic event. The isolation for all generator manufacturers now is very sophisticated, and generally these generators are tested on a shaker table to assure that isolation is proper and that it's not enhancing and exacerbating the seismic events. If you go put springs under the tank, you're just going to mess that all up. If it's a natural gas generator, then of course you could put the springs under the frame. But again, don't do that. Please don't do that. Typical engine options. We've got over here a secondary water filter. That's typical in prime units, a secondary filter with a water separator. And the water comes down here and you can drain it off, and you can actually switch back and forth and drain off the water and actually replace the filter unit while the engine's running because you have a spare. And you can see some other typical options there, but I want to get into more that I think we get questions about. Typical tanks are 8, 12, 24, but tanks are all over the place, and it depends upon the base size of the tank. And typically tanks are actually 12, 24, and 36 inch, but they could be 30 inch. And think about the tank. If you need a 24-hour tank, fine, get a 24-hour tank, but now you've got 24 hours of fuel to maintain. If you don't need a 24-hour tank, think of getting something smaller that might have less fuel that you're going to have to maintain. This is a tank on the bottom. I think this is wonderful because you're not going to get to see this when your tank gets to the field. On the end here is your conduit opening. Here's your emergency vents. Those are options. They are only required on legally required or emergency generators. They're in case the tank explodes. Those blow off and prevent the tank from rupturing. Here's your normal vent that allows it to breathe, your fuel fill, your fuel return. Here's your fuel levels. And inside, you can see that we have baffles that prevent sloshing to some degree. And when they fill the tank, that kind of helps to not stir up things on the bottom. Excuse me. Over here is a sensor that will sense that. Notice this is a double wall tank. Everything we sell is a double wall tank, double wall on 5 sides, and only the top is a single wall. If you have a leak into this leak detection area, then or the leak basin, then this will alarm. So that's a nice little cutaway that kind of shows you what it looks inside. Special. We could spend forever talking about specials. This is a fuel spill box that if you are filling the generator with fuel and you spill, it goes into this box, and then you can lift a little lever and let that drain into the tank. This is quite unusual in the picture because that really messes up your mounting, where you're supposed to put the generator, right? So if you have something like that, you typically have to extend the generator or the tank out beyond where the generator mounts, and we can put fuel spill boxes. Not common, and you can see some of the other options there. I'm not going to go through all of them. There's lots of diesel fuel options. The tank, if you're going to put it outside, make sure there's the standard tank like this, the 142, and then there's the 2085 tank. That's the cement tank. That's the mother of all testosterone-based tanks. It's got 6 inches of concrete all the way around. We don't see many of those, but they are available. The system, you can read some of the things in there that are necessary whenever you have an outdoor tank. An outdoor tank gets less reliable because now you've got to have fuel pumps and fuel level systems and so on, and everything can fail. This is a day tank. Inside, this would have a main tank mounted outside. This is Tremont. They have tended to be kind of a standard in the industry, although there are many other manufacturers of day tank. Notice that this tank is also kind of a double wall type tank, and this will keep track of the level in the tank and turn on the pumps in order to add more fuel from the outside tank when it's necessary. If the main tank is lower elevation, then you got to have a day tank pump, gravity return, engine return. If the main tank is at a higher elevation than the day tank, then you have isolation solenoids, a return pump that's size larger than the inlet flow, and you may need a fuel cooler because now the return fuel from the engine is going to the day tank rather than to the main tank. Gas fuel systems, there's natural gas, LP vapor, LP liquid, that stands for liquefied petroleum, but typically we use propane. Then you have dual fuel, that is a natural gas generator that automatically switches to propane in the event that the natural gas system fails. Or we can have bifuel, that is a generator that runs on either 100% diesel or a combination of diesel and natural gas. Much cleaner, and we have those factory. Generac's the only manufacturer of those things. Other people can retrofit them, third parties, but we have 500 and 600 kilowatt diesel generators that come from the factory as EPA certified biofuel. Here is your natural gas system. We have covered this in previous seminars, but this is very important. You want to have a regulator near your generator, but then you want 10 feet of pipe approximately between the regulator and the generator. That acts as an accumulator just to make the fuel system more stable and to assure good starts. Now, that doesn't mean that the regulator has to be 10 foot away from the generator. You can take your piping down, put a couple of 90s in there and bring it back. You just need 10 feet of pipe to store some gas. Typically, the fuel pressure is 5 to 14 inches for less than 60 kilowatts, 11 to 14 up to 300, and 2 psi typically larger than 300. About a little over 27 inches is 1 psi. So you can see we're going from, maybe a fifth of a psi to a half of a psi for your smaller generators, and a little less than half of a psi for most of, or around half of psi for 300 kilowatts and below. Make sure your piping size is appropriate. This is the biggest problem we have on natural gas generators. People undersize the pipe. As I mentioned earlier, Power Design Pro, the free generator sizing software from Generac. You can get it it's free from www.generac.com, and it has a provision there if you have a natural gas generator to size your pipe for you, and it will have all of the gas flows and pressures right there. You just put in the length of your pipes and how many T's and 90s and so on. It will tell you what size pipe to use. Here's LP Vapor. The problem with LP Vapor is the tank must be able to vaporize. We still want 10 feet to our generator between the primary regulator and the generator, 10-foot pipe length, not distance. And you've got to be able to vaporize. Now, it vaporizes, the tanks get colder, and that's the reason we use propane rather than butane, is it vaporizes much better. And so my rule of thumb here is that at minus 10 degrees Fahrenheit, which seems, pretty reasonable in this area, not that it can't get colder, but that seems like a reasonable level to me, is a 500-gallon tank can vaporize enough fuel to run a 25 kilowatt generator. Now, a 500-gallon tank to me is kind of a big tank. It's a fairly good sized tank, and yet 25 kilowatts, it doesn't seem like very big. So if you have a smaller tank or you're over 25 kilowatts, the system isn't going to work well. So what you have to do then is go to a liquid-based system. In the liquid-based system, the pipe here, the fuel inlet, goes to the bottom of the tank, maybe a couple of inches, 1 or 2 inches off the bottom of the tank. And then you need to have a vaporizer. And the vaporizer can either be on the tank or it can actually be in the generator. Vaporizers are not very expensive options. And you can order the generator with a vaporizer. It will, of course, have to have a block heater if you have a vaporizer. And then you can vaporize, and that way you can use very small tanks and still run fine because the vaporization occurs within the generator. And this vaporizer, typically with codes, needs to be mounted outside. So the best thing to do is just mount the generator outside. But if you want an indoor generator and you want a vaporization, then it's a little more complicated. The vaporization has to be mounted outside before it goes into the building. There are some other things that we need to worry about. Isolation valves, I highly recommend that the isolation valves be padlockable in the open position so that somebody doesn't accidentally turn off the natural gas to your generator. Here's some typical options. Oil heaters. We generally don't recommend oil heaters. We don't want a heater in the oil, aging that oil. But when we get to very, very cold situations, maybe up on a mountaintop where it gets really cold, we may look at putting in an oil heater. We never put in heaters in the tank for the diesel fuel. That would be virtually impossible to create a heater that large. And again, that would cause problems with your diesel fuel. So we need to make sure that that just has anti-gelling compounds and is appropriate for the level of the temperature, I should say. Make sure you don't get gelling of the diesel fuel, which of course is a big problem. Lead acid batteries are typical. NiCad, people experimented with those a ways back, but nobody uses those anymore on generators. Some people feel like lithium batteries may move into the generator field, but we have not seen them. So with engineers and with customers, it's just standard to use lead acid battery. Should have a float equalized charger. We like the 10 amp charger. It can charge the battery quickly, and then when it measures the voltage on the battery and then just floats the battery at the required level, so it only puts enough charge into the battery to keep it at its optimum charge. Smaller generators can come with 2 amp trickle chargers. not as good, but if you're buying like a residential generator or a smart commercial generator, or maybe even a small industrial, that is standard, and 10 amps, it costs a little more, but we typically tend to recommend it and to put it in. Your batteries, let's assume that your battery is 100% at 80 degrees and the engine cranking power is 100%. So that's just a definition there of what it takes to do that. When you go to 32 degrees, then the battery cranking power drops to 65%. In other words, you're cold cranking amps. And it becomes over 50% harder to crank the engine. If you go down to 0 degrees, now the battery cranking power, the cold cranking amps, is only 40% of what it is at 80 degrees, and your engine is more than twice as hard to crank. So a nice option here is a battery blanket option. They can be wrapped around the batteries, as you see in the picture there, or it can just be flat and put under the batteries. They have their own thermostat. They keep the batteries warm enough to get good cold cranking amps. They don't take a lot of power and they don't cost a lot. So it can be a nice option. More important for natural gas than it is for diesel, but sometimes a nice option for diesel as well. Governors typically are electronic these days, and they will keep your frequency within 0.25%, and that is pretty standard. Strip heaters, we generally feel, are not necessary in this area because it's got non-hygroscopic insulation in the alternator, and we just don't see problems with moisture on these standby generators, particularly because the engine has some heat going into it. It's right there by the alternator, and all you need is just a little bit of temperature above ambient to keep any condensation from occurring. On the other hand, if I were shipping a generator to Hawaii or Costa Rica, then I would probably put in a strip heater and tropical coating. Not necessary here, but can be nice in warm, humid environments. PMG is a permanent magnet generator. We're going to talk about that in detail when we get to our alternator class. And we are required to have permanent magnet generators in legally required and emergency generators. And if you do that, then as you can see here in this picture, it's actually 2 more rotating machines, one for your brushless and one for your permanent magnets. Circuit breakers, I'm almost done here. I'm going to have to go through some of these fairly fast. This is a pet peeve of mine because circuit breakers, I think, are the biggest scam in the electrical industry. You get a circuit breaker that's not that big and it can cost as much as a car practically. So we tend to say, go with your standard circuit breaker. If it's an 80% circuit breaker, it can still run at 100% in the generator, but only in the generator. If you were to take it out of the generator and put it into a switchboard, then it follows the 80% rule for switchboards. But in the generator is UL tested at 100%, so I don't see any reason to spec a 100% breaker. Typically, LSI breakers are also kind of a waste of money. For the cost of an LSI 100% breaker, you can upgrade to a sound level 2 enclosure, and I would much rather have that. Typically, these breakers never trip. It is the controller on the generator which actually controls the trip, and the breakers are more just a shutoff. Having said that, if you have an emergency generator or legally required and you need to do breaker coordination, then maybe you have to shell out and put in an LSI breaker so that you can do your breaker, so you can make sure that the breaker is coordinated. But I just hate that. I think that's one of those wastes of money, and you're certainly welcome to disagree with me on that. Coordination, we want to make sure that the rigging has the spreader bar up here. You can see that here's one that didn't have a spreader bar, and then those lines, the whole weight of the generators on that sheet metal in the enclosure, and it just collapses. Yes, we've seen that before. This is a generator that was dropped. Keep the system disabled prior to startup. If you connect the batteries are going to turn on the controller, and in about 24 hours, that controller is going to discharge the batteries, and then you will damage the batteries. So keep them disconnected until you hook up your control power to the battery charger. Generator in the off position, breaker open, ATS in manual, and the startup person will take care of that. Phase rotation obviously is very important, but electricians generally are very good making sure that the phase rotation of the generator is appropriate. We have conduits. Again, the terminations are generally 75 degrees. This is just standard wiring practice. Load banks are getting more popular. This is a place where we actually put a connection point outside for the load bank, makes it really nice. And you should load bank a diesel generator at least every couple of years to make sure you don't get wet stacking. This we talked about in our ATS class. 3-pole ATSs, the neutral's bonded at the service. 4-pole ATSs, the neutral's bonded at the generator. Do not bond the neutral to ground at the generator if you have a 3-pole transfer switch. This is a picture of a block heater or a coolant heater, kind of the same thing, and that's what keeps your engines warm. Other accessories that you can have, here's a little load center. That's an option. Cost what, $300 or something to put in there, but it can be nice because then you can bring one feed into that, and then your controller and your block heater and all are on separate breakers coming out of that. It's a nice feature, not standard on any generator, but available as an option. Here are your controllers. We talked about those last week. Make sure that if you have a legally required emergency generator that meets NFPA 110 level 1, and that you have a remote annunciator, and there is a copy of that. If you need communications, communications is available on all NFPA 110 controllers, typically not available on the others, the residential and the light commercial. And here's some of your control wiring. 2-wire start is standard from the ATS to the generator. So that's it. And I will turn the time back to Mr. Tyler.
Great. We had a couple questions come in. Feel free to continue submitting those. Craig, the first question is, what is the specified range of dBA at 23 feet for a level 2 enclosure?
That's a great question. And the answer is there is no specified dBA range. Typically, what you're going to find is a 50 kilowatt generator with a level 2 enclosure is going to be quieter than a 500 kilowatt generator with a level 2 enclosure. So in reality, this is the only thing that level 2 gets you. A level 1 enclosure is quieter than a standard enclosure. A level 2 enclosure is quieter than a level 1. A level 3 is quieter than a level 2. But it could be that if one manufacturer makes a level 2, another manufacturer makes a level 1, it is possible that the level 1 could actually be quieter than the level 2. Although that would be unusual. I'm not saying that is typical, but there are no sound levels associated with these enclosures. And so what you need to do is a level 2 enclosure. Like I say, I'm a big fan of that because a level 2 enclosure is typically the quietest enclosure that you can get without costing an arm and a leg. And you can stand right next to a level 2 enclosure generally and have a conversation. So I recommend level 2, and sometimes that's all you need to spec. But if you really want to know what the dBA level is, you have to ask for a certain dBA level. And I would call a generator manufacturer before I do that. We'd be happy to talk to you about that, because if you, let's say you specify a certain dBA and you kind of pick something out of the air and say, I want about this much, and then we're 1 dBA lower than that, we may have to go up to the next sound enclosure, which may cost a lot of money. And so it's a good idea to talk to a generator manufacturer and say, okay, I got a 500 kilowatt generator. What are the sound levels for weatherproof level 1 and level 2? And then make your spec accordingly so that you don't end up paying a bunch of money that you never really intended.
All right. For block heaters, what kilowatt size of generator changes from 120 volt source to 208 volt source required by the electrical contractor for the power?
Good question. So block heaters, also called coolant heaters. What you didn't ask, but I will answer, is what should the kilowatt size be? And the kilowatt size generally is based upon the engine manufacturer's recommendation. So we generally don't say, oh, you need a certain amount of kilowatts for a certain size generator. We go to the manufacturer and say, what does the engine manufacturer recommend? Typically, those block heaters are sized so that the outside can get to 20 degrees Fahrenheit below zero, and the block heater will still keep the engine at operating temperature. Although it's going to be working pretty hard at that point. So if you really think you're going to be below 10 degrees Fahrenheit, I might think about going with a larger size block heater. Block heaters, as you know, are one of the things that fail a lot in a generator. Now, to your question, most smaller generators will have a 1500 watt block heater. So if you take 1500 watts and you divide by 120 volts, then what do you get here? 1500 divided by 120, you're getting a little over 1 amp there. Did I do that right? 1500, 150, yeah, divide by 12. Now I'm questioning myself. In any case, the 1500 block heater is the largest size that you typically get 120 volts on. And we don't even generally talk to people about that because everybody has 120 volts. And your 1500 watt block heater at 120 volts will be kind of standard. When you get above 1500 watts, then we typically go to a single phase block heater that is either 208 or 240. Now, if you have a 240 volt block heater and you run it on 208, it still works, but you only get 75% of the heating, the square of that ratio. If you have a 208 volt block heater and you put 240 on it, you're going to burn it out fairly quickly. So those are single phase block heaters, and this is a very important thing that we need to check whenever we order a generator is, are you going to feed it with 208 or 240? Because typically it's an option that we have. We can configure that generator with either a 208 volt block heater or 240 volt block heater. And then as you go even larger still, then you may get to the point like you got a 1500 kilowatt generator. Now you're the point where you're going to go to higher voltages on the block heater, and it's not uncommon to have a 480 volt three-phase block heater. But the simple answer to your question is the change from 120 to 240 or 208 happens when you go above 1500 watts. Yeah.
Someone asked, I saw something on the slide about block heaters and summer temperatures. Could you speak to that?
And summer temperatures, is that right?
Yes.
Yeah, so in the summer, you've got the sun shining and it's shining on that enclosure. Typically, even in a situation like that, the engine might still need a little bit of heating, but mostly at like 100-degree day, sun shining on the enclosure, you don't need any block heating. Every block heater comes with a thermostat. And so when heating is not required, the block heater doesn't provide any heating. It's not on all the time. It is only on when the engine goes below the temperature that we need to require. And so the block heater is going to typically go on and go off and go on and go off. And even if it's 0 degrees out there, or even minus 10 degrees, the block heater is going to be on more often the colder it gets, but it's still going to go on and off. It's not going to stay on all the time, pretty much ever. Let me go back, just talk about the block heaters in a minute. And I'm sorry, I got a little tongue-tied. If you have a 1500 watt block heater, it's 120 volts, it's going to take a little over 10 amps. And the good thing about that is even a 15 amp household circuit, typically these small circuits that feed receptacles and so on are 15 or 20 amp. And so you can feed it with just a standard 15 or 20 amp circuit to the generator. And in fact, you can, with a 1500 watt block heater, you have enough power left over for the battery charger and maybe for a battery heater, and you're still good at a 20 amp circuit. When we go above 1500 watts, then we get into amperages that are high enough that we feel it's probably better to go to a higher voltage, so you can use smaller wire and smaller circuit breakers. It's also helpful for the block heater to have a higher voltage when you get into higher kilowatt values.
If you are planning a project, what is the typical time frame you see installations and startups take that you should plan for?
Installation and startup. So let's start assuming that you have chosen a generator and that you have ordered that generator. Typical lead times on generators are 6 weeks to sometimes a year. I mean, I've never seen Generac with a 1-year lead time, but I certainly have seen other manufacturers have over a year's lead time on a 2 megawatt engine. So typically with Generac, we will see 6 weeks on some of the smallers, up to maybe 12, 13, 14, or even 15 or 16 weeks as you get into the 1 megawatt, 1.5 megawatt units. Now, shipping can depend upon the trucks. And so sometimes we've found, we talk to the transportation company and they're saying, oh, I can't get a truck for 2 weeks. Well, that could be a problem. Typically, that's unusual, but things can sit there if you don't check on them for more than 2 weeks, just waiting for a truck going to your area that happens to have space on it for your size generator. For the most part, shipping takes about a week. Installation, of course, depends upon the contractor. So if the contractor is on the ball and he's already got his cement poured and he's got his wires run and he's set, installation can take a couple of days. If it isn't critical and you don't have to have an outage. In fact, in some cases, installation can take 1 day. If you've got an outage, they may do the installation in 10 hours. But typically a week is plenty for installation, assuming your contractor has you scheduled and shows up on site. And then the startup, we like to have 2 weeks advance notice of the startup, because even though we have a lot of startup engineers, they're not just sitting around. They are scheduled and we like to keep them busy. And so we really like to have 2 weeks notice of when you would like the startup to occur. And you need to verify when you request that startup that the installation is done, because the last thing you want is for us to show up on site to do the startup and the contractor hasn't finished installing it yet. And then the startup typically takes, for a smaller generator, 1 day or sometimes a portion of a day. If you've got a system with multiple generators, MPS that are large, it could take several days, but typically startup's a 1 day deal.
Great. It looks like that's all the questions we had. So we want to thank everyone for joining us today. We look forward to seeing you next time.